In this video, we're going to go over a specific type of direct variation problem where you're given a table of data and then asked whether or not y varies directly with x. Let's dive into it. I'm also going to graph it too, by the way, which is pretty sweet. Does y vary directly with x? If so, write an equation that relates y to x. So what does it mean to vary directly? Well, in an earlier video when we talked about direct variation, we basically want to know, can we get an equation such that you get y equals k times x? So that's the question. If we can get an equation like y equals k times x, another way of looking at this, and this is pretty cool, is if we were to divide both sides by x. Watch what happens when we do that, and I'll do the work down here. So if we have y equals k times x, and we divide both sides by x, we end up with k is equal to y over x. So that's really the question. The question isn't so much, can I get that equation? A better way, I think, in my opinion, of asking it is, can I get a constant of variation that is constant, the same? And if we can, then we have direct variation, because then we have that same number every single time. So you're basically taking the y value and dividing it by each x value and seeing, do you get the same number? And that's from that idea. Isn't that cool? So let's use this idea. So I'm going to divide 7 by 2. Right, so I'll do that work off to the side right here. So 7 divided by 2, and I'm going to get a decimal, is equal to 3.5. Nice. And then I'll do 10.5 divided by 3. And you can use a calculator for this if you like. And that is also equal to 3.5. Ooh, so far so good, but we've got to check them all. 14 divided by 4. So 14 divided by 4 is also 3.5. We have one more. We'll do 17.5 divided by 5. And when we do that, we're going to see that we have a constant of variation. And that constant of variation is 3.5. So the answer is yes, y does vary directly with x because it has a constant of variation of, well, a same value, in this case 3.5. So it says, if so, write an equation that relates y to x. Well, that's the easy part. Since I know that k is 3.5, I'm just going to enter k into this equation. So y is equal to 3.5 times x. And that now is our direct variation equation. One thing I wanted to point out is if you were to plot these points on this graph, and I'll do like a rough graph here where we go up by, let's say, 1s on the x-axis, and we'll go up by, well, I don't know, 2s on the y-axis. So the point 2, 7 would be 2, 2, 4, 6, 7. So there's 2, 7 right there. 3, 10.5, so that's over 3 up, and then here's 8, 10.5 is roughly right there. And then we have 4, 14, that'd be 4, and then here's 12, 14. Make sure you guys can see that at home, make it nice and dark. And then 5, 17.5, which is 5, and then up here 16, 17.5. Now the point that I want to show you is that if you were to draw a line through this, and I'll kind of dot it right here, just kind of sketch it, that line's going to go through the origin, which is not a shocker when you dive deeper into understanding how to graph lines. So for now, I'm just going to say, yeah, that line for direct variation goes directly through the origin every time. Something neat to point out. On the flip side of this video, I'm going to do one more of this exact same kind of problem just to make sure you got a decent idea of it. It's going to be an example of when something does not directly relate. See you on the flip side. And here we are on the flip side of our direct variation video where we're looking at tables of data and figuring out whether or not y varies directly with x. So as we saw in the first problem, what we often do is, well, not often, but almost always, is solve this equation. And we saw that in the beginning of the video for y equals k times x, and that gives us y over x is equal to k. And the question becomes, do we get a constant value when we divide y by x? And if we do, then we know that we observe a constant of variation and a direct variation situation. So we're going to do that same test now with this data. We'll take y and divide it by x. Well, that would be 30 divided by 1. So 30 divided by 1 is equal to 30. So if we get 30 every single time, then we will have a constant of variation and of 30 and direct variation. We'll try 15 divided by, oh, no, I think that's where the buck stops. 15 divided by 2 is 7.5. there's no need to test any further because what we've realized is we do not have a constant of variation when we solve for k. So this is not a situation where y varies directly with x, so there's no direct variation. I also want to show you that you don't get a line that goes through the origin like we did with direct variation in the last part of this video, or I should say in the first part of the video. So let's just plot these points out. So 130, well, we'll go up by 3's on the x-axis here, so on the y-axis. So 130 is up there, and then 2 comma 15, so that's going to be 2, and then 3, 6, 9, 12, 15. And then 3 comma 10, so that's going to be over 3 and up 10 is roughly here. And then 4 comma 7.5, so that's going to be roughly like right here. We see that this is more curved than anything. So it's definitely, and I'll draw in the rest of that curve right there, just sketching it in. That's definitely not a line, definitely not direct variation, but I wanted to show you that we see that as x gets bigger, y gets smaller. That's actually something you'll learn down the road called inverse variation. It's the opposite. Remember from our first videos in direct variation, as x gets bigger, y should get bigger. Or as x gets smaller, y should get smaller. That's the direct variation. That's it, peeps. I hope you enjoyed it. See ya in the next video.